Systems by Algebraic Methods is a two-part lesson. Today we are on the first part. Today we're talking about substitution. Okay? How many of you have animals? A lot of people have animals. Any of your animals ever have babies? It's okay if they haven't. You can imagine, right? So what if we're talking about the runt of the litter? The smallest, the baby, the littlest. So talking completely not incorrect math vocabulary in any way, shape, or form, which one of these variables do you think would be considered the runt variable? Which one's the smallest, the littlest? Well, between these two equations, I see x and y as possible runts because there's no multiplier in the front. See how this x has a 7 multiplier, this y has a 4 multiplier? Neither one of these really have a multiplier, except this y kind of does, doesn't it? What is this y's multiplier? -1, right? So if we're talking about runts, completely pure, we want to get all the way down to just the variable, we're talking about this x. Okay? So what we want to do is we want to see the first set of directions here says solve for a variable in one of the equations. We want to choose the runt variable. Now, again, let me be very clear. That's not correct mathematical vocabulary at all. Okay? You look it up, you're not going to find a runt variable. That's just me. I'm trying to relate it to something you already understand. Deal? Okay? So what we need to do is solve for that variable. I need to get that variable all by itself. How do I do that? Can I add y to both sides of the equation? When I add y to both sides of the equation, what I end up with is x equals y minus 11. You okay with that so far? This is where the substitution comes in. Okay? Do I know what x equals? You might say no because it's not like a number, like an integer or something like that you're used to. But do I know what x equals? Y minus 11. Okay? So I'm going to go to the other equation that I didn't use. Whoops. And I'm going to rewrite the equation, except wherever it says an x, I'm going to instead write y minus 11. Because that's what I know that x equals. So I have 7 times, not x, but y minus 11. Then I keep writing this equation. Plus 4y equals negative 22. Okay? Oh my gosh, I really wish we would have really studied solving equations. We did, right? Isn't this what they look like? And I kept telling you guys, you have to trust me that things are going to show up like this and we're going to have to know how to solve them. Look, I proved my trust. Look, we have to solve this. Let's distribute the 7 and distribute the negative 11. What do I end up with? 7y minus 77. Excellent. Plus 4y equals negative 22. Now, here's something I need you to be very, 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 very careful about. Even on this last test, there were still people that messed it up. What do I do with those? Why can't I just add them together? They're on the same side of the equal sign. I don't have to subtract 4y and subtract 4y because they are on the same side of the equal sign. I just combine my like terms. I have a 7y and a 4y. What is that? 11y. Minus 77 equals negative 22. Very, very good. Add 77 to both sides. 11y equals 55. Divide by 11. Y equals 5. So that's the answer. Why not? Why do I care? One of our big 3 points from last week was, where is the solution to the system of equations? Where is it? Where's the solution to the system of equations? Graphically, where is it? It's the point where they cross, right? The point where they cross. Okay? And so if it's the point where they cross, is it good enough for me to just know y? What else must I know? How am I going to find x? Plug it in. Substitute, right? So substitute again. Where do I substitute my y? Where? So like here? Here? Why not? Could I here and here? Yes, but x already is solved for right there, isn't it? Excellent. X equals 5 minus 11. What is 5 minus 11? Negative 6. So that's the answer. No? Why do I have to? It's the point of intersection. I have to write my answer as a point. Excellent. Any questions? Okay, so let's start slow then. Okay? Let's just look at this system right here. Just looking at the system, which one do you think is the runt variable? Which one? What do you mean the top one? There's two variables in the top equation. The top y? Why do you think that's the runt? Doesn't have a multiplier and it is positive, right? Okay? So what about the second one? We're starting easy. We're just looking at them right now, right? The bottom x, and why do you think the bottom x? It's positive and doesn't have a multiplier. Okay, what about this section? Uh-oh. Why the top y? Doesn't have a multiplier. Okay? Doesn't have a multiplier. And what about the last one? Why would you choose 2x instead of 3x? Because it's smaller. Okay, it has a smaller multiplier. Any questions about that? Okay, so look at number 1. Oh my gosh, number 1 is this one. Huh. Which variable are we going to solve for? The first y. Okay, so what do I do to solve for y? What do you mean move x? Subtract 4x from both sides. Y equals 3 minus 4x. So somebody said, but that's not slope-intercept form. What did I say? Who cares? I didn't really say who cares because that would be kind of rude. I might have said it inside my head. You will never know. Okay? Are we trying to graph here? No, we're just trying to get what y equals. And if we want to write 3 minus 4x, that's perfectly fine. Okay? What do I do with what I know what y equals? Plug it into the other equation where y is. So 7x plus 2 times 3 minus 4x equals 4. Does that make sense? Okay. Distribute, distribute. 7x plus 6 minus 8x equals 4. Now what? Combine your like terms. If they're on the same side of the equal sign, just combine them. 7x and negative 8x. Negative 1x plus 6 equals 4. Subtract 6 from both sides. Negative 1x equals negative 2. If negative 1x equals negative 2, then x equals 2. Just 2. Is that good enough? No. Plug it in where? Back over here. Y equals 3 times 4 times, or 3 minus 4 times 2. So y equals 3 minus 8. So y equals negative 5. Is that good enough? What's good enough? 2, negative 5. That is good enough. Is it correct? How do you know? You could put it in the calculator, but in this case that would mean like solving it all, right? For y. I don't want to do that. I could plug it in, couldn't I? 4 times 2 is 8 plus negative 5. Oh, that's right. 7 times 2. 2 times negative 5. 14 plus negative 10. Oh my gosh. I got it exactly right. Now, am I going to force you to plug in this answer, like over here to the side, to check your solution? What will I expect you to do? What I just did for you. Do it in your head. And if we start to get a bunch of these wrong, then we'll start to write it down. Is that a threat? Yes. Okay. Number 2. Where's our runt for number 2? The second x? How do I get the second x by itself? Add 20 on both sides. So x equals 7y plus 20. What do I do with it? Take this and plug it in for x. Right there, right? So 9 times 7y plus 20 plus 11y equals 32. And now? What's the math word? Distribute. Excellent. Here and here. 9 times 7? So smart. Very good. Now what? Combine the like terms on the same side of the equal sign. 63y and 11y. 74y plus 180 equals 32. Subtract 180 from both sides. Very good. 74y equals negative 148. Divide both sides by 74. Y equals? Can you do it in your head? Did you do that in your head? What do I do with it? Aki? Aki or ai? Why? To me it's Aki because it's right here, but to you guys it's up there, right? So should I say ai? There. Here and there. Okay, we can have a Spanish argument later. Is that okay with everyone? So x equals negative 14 plus 20. So x equals 6. 6, negative 2. Is it right? 9 times 6 is 54. 11 times negative 2 is negative 22. 54 and negative 22, 32. 7 times negative 2 is negative 14. 6 minus 20, negative 14. Guess what? 2 in a row. Got them right. Questions? Turn the page. Number 5. Which one's the runt? The what? Which y? First y? Okay, so what do I do to solve for it? Subtract 5x from both sides. Y equals 2 minus 5x. Take 2 minus 5x and plug it in right there for y to the other equation. 10x plus 2 times 2 minus 5x equals 9. Distribute. 10x plus 4 minus 10x equals 9. 4 equals 9. 10x minus 10x is 0. Ooh, what did I do? Did I do anything wrong? Does 4 equal 9? So something's wrong. Did we do anything wrong solving this equation? Does 4 equal 9? Does 4 ever equal 9? Okay, we'll come back to it in just a second. Look at number 6. Which one's the runt? Probably the 2x, right? Or right here. So let's add 6y to both sides. Hey, let me make something real clear to you guys. When I say find the runt, and some of you said 2x, did anybody say negative 3y? What if she does this by solving, a negative 3x, if she solved this by solving for this x, will she get a different answer or the same answer? Same answer. And that's totally okay. Alright? I'm just trying to help you find the easiest way, but the easiest way for me is not always the easiest way for you. And this is one of those places that we're allowed to do different stuff. Okay? So I know what x equals. So I take it, put it right there. So negative 3 times 3y plus 8 plus 9y equals negative 24. Negative 9y minus 24 plus 9y equals negative 24. I have negative 9y and positive 9y. What's that? So negative 24 equals negative 24? Does negative 24 equal negative 24? Does negative 24 always equal negative 24? So we have two different situations here, right? Where did our x's go? They just subtracted to 0, didn't they? Okay? So when we're solving a problem algebraically, if we end up with an equation that is not only not true, but never true, the system has no solutions. Or it is inconsistent. Very good. You remember that vocabulary from Friday? Hopefully. Graphically, the word you guys tried to tell me a second ago, graphically the equations would be what? Parallel. Okay? Graphically the equations would be parallel. Does anybody remember the symbol, the symbol I could use for this one? Do you remember what that means? It does represent no solution, but do you remember what it means? It means the empty set. Okay, you remember that? There's no solutions in the set, so it's an empty set. Okay? So what about here? If you end up with an equation that is always true, the system has infinite solutions. Nice. Or it is consistent, yes. But remember, there was two kinds of systems that were consistent. What separates this one from the other one? It is also it's also dependent. Graphically, the equations lines would be on top of each other. Who else said something else? Coincide is the word we used the other day. That doesn't really make sense grammatically in this sentence. So can we just say the same? We'll go ahead and put coincide because that's the word we worked on last week. C-O-I-N-C-I-D. I suppose we could make it into a gerund and say coinciding. I agree. But we'll leave it like that. Is that okay? Okay, so this is what I need you to know. 7, 8, 9, 10, homework. And number 4. Okay, so number 4 on the first page, and then 7, 8, 9, and 10 on this page. Gives you 5 homework problems, gives you 1 extra problem to do if you wish extra credit. Any questions?